Hi, everyone. Welcome to the Empowerment with Power BI webinar series. We are really excited to share some great information. We hope that it'll be very valuable. We're going to give people just a couple more minutes to sort of log on. So in the meantime, just relax a little bit and we'll get started shortly. All right, everyone. Thank you so much for registering and attending this webinar. Our speaker today is Tarun Agarwal. He's the Director of Data and AI at Motifworks. He has tons of background experience with Power BI, so we're really excited to have him here today to sort of share his input and share some of his knowledge. At this point, I'm going to go ahead and pass everything over to him, and he's going to go ahead and tell you a little bit about himself, and then we'll launch into the content for today.
All right. Thank you, Sarah. Thanks for the welcome. Hello, everyone. Good morning, good afternoon, good evening, depending on wherever you are logging in today to attend this webinar. I appreciate your taking time off from your busy schedule and joining the webinar to learn about the Power BI empowerment. Just before we get started, a brief background about myself. Like Sarah mentioned, I am the Director of Data and AI Practice at Motiveworks. Motiveworks is a Microsoft Gold partner and a cloud solution provider company. Prior to joining Motiveworks, I have a wealth of experience building and strategic data-driven solutions at large organizations and really leveraging data culture at the organizations. At Motiveworks, we are focused on enabling our customers to leverage Azure Data Services platform to build data and AI initiatives. Brief background around Motiveworks. Like I mentioned, Motiveworks is a Microsoft Gold partner and a cloud solution provider company. We are a company which is born in cloud, and we always have cloud first thinking. And we help and work with our business, our clients and our partners to accelerate their digital transformation, to build agility in their IT infrastructure and workloads, use their various applications, intelligent applications and data initiatives to drive decision making, and really give access to the data by building connected enterprise. And how we do that is by elevating their current IT infrastructure and migrating their existing infrastructure, data center, or other workloads in cloud, modernizing their applications, building using cloud PaaS services and cloud native services, modernizing their data platforms, bring innovation to their product and services by building digital products and cloud native applications, leveraging data and AI and machine learning, and also help them operate their environment and infrastructure by providing managed cloud services and any other on-demand cloud consulting services that they're looking for. We have all the right credentials to be Microsoft partners and provide certified resources and valuable expertise to our clients. So like Sarah mentioned, we are having this series of webinar to talk about how do we enable empowerment in organization using Power BI. This is third webinar in the series of 5. We have looked at how can we replace Excel-based reporting using Power BI's and user reporting kind of solutions. We looked at how do we create data models and data shaping by leveraging various kind of Power BI query editor features and mQuery language. And how do we really build our data models that is really allows to support the various powerful reporting that can happen through Power BI. Today we are gonna take our learnings in last 2 webinars and one more step further and talk about how can we build complex transformations, which is mainly around using DEX language in Power BI and build various complex calculations transformations using various functions and features of DEX language. So just a quick refresher for what we have learned so far in last 2 webinars. Power BI allows you to experience your data, any way, anywhere you want, whether it is coming from and generating in born in cloud, or it's coming from your on-premises data sources, whether it is a structured, unstructured, relational, file-based, batch, real-time, you name it. Any kind of data that you want to use and to analyze, you can bring it in Power BI and consume it anywhere you want, whether you want to consume it on browser, on your mobile phones, inside Excel, inside your own business applications or web applications. You want to embed Power BI, everything is possible. It depends on what is your need and how your users would like to consume. So talking about users, what are end user needs? And I think we saw in earlier webinars that we are in the third wave of BI, which is really end user BI, which is enabling end users to do their own data analysis. And what do they need to do their own data analysis? They need an ability to access the data. They should be able to access well and bring the data that they need. They should not depend on other people or IT teams to prepare or build the data. They need to clean the data because data is not always in perfect shape or form before we can start to analyze. So they have some data issues and data anomalies and inaccuracies. So users are looking to clean the data so that it is ready for consumption. To combine the data and create data mashup, we spent a lot of time in the last webinar to talk about data mashups, to explore the data, and then to visualize the data by building all the different kinds of visualizations. And once they have the right data inside that they're happy with and they're looking to drive the businesses, they would like to share it with their other colleagues and business leaders. So Power BI allows you to do all of those things inside its ecosystem. And we also looked at briefly, it has more than 115 data source connectors that you can use to bring the data in Power BI. And we talked about any kind of data, whether structured, unstructured, cloud, relational, any kind of data can be consumed inside Power BI. We also looked at how can we use Power Query Editor to clean the data and combine the data and create data mashups in Power BI that allows and that prepares the data or shapes the data in the form that is ready for consumption. And then we also looked at Power BI allows you to create various kinds of visualizations to really build a story around your data. And in the last webinar, if you guys recall, is all of those people who also attended last webinar, we built this kind of a star schema model using the various different kind of data sets we had, so that made it ready for consumption. So just a quick refresher, we build dimension table, which are like that, tables that contains and host reference data around your customers or product or any other dimension that you have. And the fact table is a collection of all the measures or KPIs that is driving the kind of data analysis you're looking for. So those all are combined in your fact tables, which is at the center. And you join these tables using what we call as relationships. And most common relationship is one to many. because all your dimension tables will have one record, and there will be multiple records in the sales table or the fact table. And we also talked about various other flavors of this kind of data model, like the denormalized schema and the snowflake schema. But Power BI really likes star schema, and so we'll focus mainly on this. And so today we are gonna build on the knowledge that we have acquired and talk about how can we build a complex transformation using DAX. So DAX actually stands for Data Analysis Expressions. It's a language which is very, very similar to Excel kind of formulas and functions that's available in Excel. So it will be people who are already using DAX in some shape or form, or people who are just getting started and doing DAX. They'll find that the formulas and the expressions of DAX are very similar to Excel. So the learning curve will be easier. But DAX is much more deep and much more elegant than Excel. It's not just the same Excel formulas which is available in Power BI. It is much more profound, much more powerful and compelling than Excel. It is easier to get started because it will look very, very similar to Excel formulas and functions, but it takes time to master it. You will see, so what in some of the slides that we will talk about, the different things are available in index like query language that we can leverage. So my hope and intent here is not to make everybody who is attending this webinar a master of DAX language. My hope is to give you enough exposure and enough things to get you started and do that, so that DAX sometimes may feel overwhelmed to some people because it's like, I do not know what's really happening and I do not know how I'm going to use it. So give you the basic foundations and build so that as you start your Power BI journey, you can try to use these foundation things and try to build on top of what you probably get exposure today. All right. So when we talk about DAX or the data analysis expression, we are really talking about three main things, which becomes like a foundation of the entire DAX language. At the very bottom and really the main foundation is around concept of understanding what is calculated columns and measures, and that really, once you have a very clear understanding of what is the difference, what exactly are calculated columns and measure, and what is the difference when you should use one versus the other, it makes other things easier. And then the next thing that you should learn on is around calculate function, which is similar to, it's not available in Excel, but it is similar to some of the other functions available in Excel, but it is much more powerful than Excel functions. And the biggest thing eventually, which is most difficult for people to understand, is around evaluation context, is how all these functions and calculations in Power BI DAX really works around the evaluation context. So there are two kinds of context, a row context and a filter context. And how DAX, depending on what visual you are trying to do, how it changes from row context to filter context, sometimes it becomes a little bit overwhelming for many people. So my hope is, if you understand enough basics around what each of these things are, your journey of mastering DAX will become easier. All right, so let's talk about calculated column and measured. So what is a calculated column? So before we jump into calculated column, let me see if I can bring my Power BI. So if you recall, we built last time a data model which was very similar to the data model using the same data set. We had all the sales data was coming from a sales in a fact table, which is sales, and we build our dimensions around the sales table for product, customer, campaign, and date. And zip code also has it's like a snowflake kind of a schema where zip code gives you the city, state, and country level information for each zip code. So this is what we built. And if you go to your, this is your relationship thing, and if you go to your data model thing, you can see that the data for each of these things, which is really coming from the Power Query transformation and data shaping we did. So if we have to build, so if you see here, Each of these things that is coming from Power Query are actually columns which are coming from your data sources. But you may need additional columns which are not available in that is coming from a data source, and you want to create it here, which is called calculated column. So calculated column is like any other column, which is gonna become which is gonna be evaluated like a column at every row level. So if, for example, I see like I have unit price and I want to create a column for, let's say, price band, and actually we can just switch it back here. So calculated column, like I was talking about, it's a column that it gets calculated at for each row. When we build all our Power Query transformations and data shaping, and we load the data in Power BI, all the columns and the transformation gets compressed and get available in Power BI. But that time calculated columns are not there. Calculated columns are going to be applied on top of all the columns that you have already brought in from Power Query editor, and it will be calculated for each row level. Whereas a measure is also using DAX language, but it is actually not, it does not result into any value until it is used into a visual. So calculated column will calculate once you refresh the data in Power BI, and it will be calculated for each row of the table you are going to create it. Versus a measure, it's like aggregated expression. It only gets evaluated when you put that measure into a visual in a bar chart or a line chart or a table. So that's really the main difference. So I was talking about, I think if we have to create a column for price band, that I want to see if all the unit price of all the products which is less than 25 as my low price band versus anything which is greater than 50 is my high price band. How can I create a column which does not really come from my data source? Like there's no price band column here. So what I can do is I can go and say new column and create a price band column, and I can say if my unit price, and if I start typing, it knows anything which I'm looking for. I'm looking for a column unit price is less than or equal to 25, then call it low. Otherwise, I will put another condition. If unit price is less than or equal to 50, then I would like to call it medium. Otherwise, I would like to call it high. Okay, so I use this and I create. So as you'll see that when it created a new column, and you see the icon. It means it's a calculated column. So when it created this column, it is calculated for every row of this product table. So now, if I want to see the value of this, I can put in my product names. So you will start to see all the product names, and I can see the unit price of my products, and I can see the price band, right? So you can see that it is more than 51, so it's a high. And if you scroll down in the list, you will see some mediums. It is 45, so it's a medium, and it is 20, so it's low. So like it already calculated this the value of the price band at each row level, and so that's really a calculated column. All right. So sometimes, if you recall, what I did just now is I was actually in my product dimension and I used the unit price to create a price band column. But sometimes you might want to create a calculated column which goes across tables. So for example, I want to create cost of goods sold. So which is all my number of units sold multiplied by the unit cost. So if I have to create something like this, let's say if I go to my sales table and say I want to create a new column, and I want to call it cost of goods sold, which is equals to the units that I sold multiplied by unit price. And but you see, it does not even give me unit price or the unit cost column, because it is I'm trying to create this column in sales table, whereas the unit cost is coming from the product table. And by default, it's saying, hey, I do not know what exactly are you trying to do. So it will not take it. So the way you do it is using a function available in Power BI called related. So it's basically what it did is it actually, the moment I wrote a related, using the relationship we have defined in the relationship tab, it gives me all other columns and from the tables which are related to the sales table. And I can see start showing me all the campaign and the customer level column. Now, if I type unit, it will show me the unit cost. And this is what I'm looking for. So this is what I want. I want unit multiplied by the unit cost. This is going to give me the cost of goods sold. So again, so this is a cost of goods sold column comes here and I can bring it here. And if you want to see also the unit, I can also bring in the unit column here. So now you can see how it is doing it. It's actually calculating for each row using the unit and the unit cost, which I did not bring. It's calculating the cost of goods sold. So this is really the concept of a calculated column. So this is what we're talking about is you're using a related function to go across the other columns from which is coming from other tables, which are related to the table where I'm trying to create this calculated column, which happened to be the sales table. All right. So this is very much similar to a VLOOKUP. If you guys have done VLOOKUPs in Excel, you kind of try to do something similar, but you can see how profound it is, and there's a lot of issues that we have in VLOOKUPs, like you get a lot of NA values. So those things do not happen in Power BI. So it is much more powerful than a VLOOKUP, even though functionality is similar. All right. So let's talk about a measure. So if you have to create a measure, which I mentioned that it does not have a result into a value until it is used in a visual. So if we go to a calculated measure, so you see I have already created a bar chart, which is actually giving me the sales amount. I'm using the sales amount and across categories. So it is showing me the total sales amount I have across categories. And this is not a calculated column, or it's not a measure. It is a column which is coming from my Power Query, from my data source. But it is actually doing the summation. So how did this happen? It is actually, what it is doing is any columns which are actually your measures, which are like aggregatable columns, it is doing creating implicit measures and be underlying the same. So if I click on the definition of a sales amount, what you will see is the summation function I have defined is sum. So that's why when I bring it here, it is actually doing the implicit measure and it is summing up all the sales amount across the categories that I'm looking at. But if I change this to anything else like count, it will not show sum, it will start showing you counts, right? So that's the difference between, that's why it is, even though it is coming from your source, it is not really it's an implicit measure, but sometimes we also want to create the measure that we want to control, and it should result into a value when we actually use it into a visual. So I can create go to my table and say new measure, and I can say I want to create a new measure which is total sales, which is nothing but sum of sales amount, right? Very simple. Total sales, sum of sales amount. So now if I recreate same kind of a visual, another bar chart using my category and total sales, you will see that it looks exactly the same, right? Even though it is using different measures, because implicitly sales amount which is coming from the data source is actually also doing an implicit sum, and I'm also trying to do an explicit sum using my total in the measure that I created. So that's a concept of default summarization, using the columns which we are coming from the data source by using the summation expressions that are used versus a measure I created myself. All right. So we talked about what is a measure, how it gets, it does not have a value until it's used in a visual, and it's applied on the, not individual row by row, it applies on the aggregate row, depending on the function, like the sum function I've used here. So finally, what did we learn about calculated columns and measure? Calculated column, like I mentioned, gets calculated when the data gets refreshed into Power BI by applying all the steps of the Power Query, and it's evaluated at each row at row by row level. This calculated column can be used into a row, a column, a filter, or even a value. If we want to, like we saw, the cost of goods sold is a calculated column, but I used it as a value. And but measure is actually, okay, you cannot put measure as a column, right? Measure is going to be used for in values, always going to show value only when it is put into a visual. All right. One other thing quickly, if you want to pay attention to, is if I go to my transform data to launch my query editor. If you recall, in my sales table, this is from the last week, if you guys still remember, when I loaded my source data, I did not have a sales amount column. Actually, I created a join with my product table, which is going to be right here. I created a product ID join, and I got the unit price column in my sales table, and then I added a new column, which is nothing but a calculation of unit price times the units. So if I want, I can also add another column here called cost of goods sold. So I can do a formula of units times cost price, right? The unit cost. So I do not have to create a column, a calculated column called cost of goods sold in my as a calculated column in Power BI, which is going to be applied after I close and apply. It gets evaluated. So any calculations which are done at Power Query level using formulas like this are always going to be much more performant than the calculations I'm going to do using a calculated column, which is a very important and performance step. The reason for that is the data, when I'm actually loading the data into Power BI, it's actually evaluating and compressing the data versus the column I created right here. It is using the data which is already compressed and applying this and creating a new column on top of that. So it will always take extra memory, the RAM, and your size of the Power BI file will increase depending on the size of the data that you're bringing. If it is a small data set, you may not notice the difference, but think about if you're loading million rows or more into Power BI, and you will see the difference in performance and the size of your file depending on if this calculation is done as a calculated column versus in Power query in the Power Query editor. All right, so moving along, calculate. So the next foundation that we should talk about is a calculate function, which is a very powerful function. So think about a use case where you have to build a report where you are seeing not only the total sales by month, but you also want to see, I not only want to see the total sales, but I also want to see desktop sales in January, which is a part of the total sales, but you also want to see next to each other. And we do not have we have just created total sales, but we do not have desktop sales. So how do we do that? How do we calculate? So calculate function allows us to create calculations like this. So this is a formula. I mean, in the interest of time, I will probably create one or two formulas, or maybe, but I don't want to take a lot of time on creating formulas. But just to show you, how are we going to create a calculate called desktop sales? And created a new column called desktop sales, which is nothing but I'm using a calculate function, and I'll actually walk you through what exactly is happening here, why I'm doing. So I'm actually creating a calculate function which is using an expression called total sales, and I'm giving a filter context, and we'll talk about filter context. And I wanted to create for desktop, so it is a device. So I'm going to say where my device column from coming from campaign sales is equals to desktop. Okay. So this is going to give me a column called desktop sales. And if I want to actually put it in my sales table, the visual I'm creating here, I think I created total sales. Let me drag total sales and let me also drag desktop sales. So what I just did is I created a measure called total sales, which is giving me total sales in the month of January. But I also created another measure, which is only giving me the total sales for desktop device in the month of January here, right? So how does calculate function work? Let's break it down. So this is how the calculate function works. First thing it is taking is an expression. So expression, the first parameter of your calculate function, is actually essentially same as a measure. So I use total sales measure, but you can have any other measure expression that is going to give you a measure. And then it actually takes a bunch of arguments as a filter. Okay, it's called filter arguments. And you can give multiple filter arguments. In our example, I only gave one filter argument where device equals to desktop. It actually becomes the filter context. I think I mentioned this word filter context multiple times. So what exactly the calculate function is doing is it's actually calculating the total sales which we created for the filter where the device name is desktop. So it at the calculation time, when you bring in this measure in your visual, it is applying the filter which I gave, that I'm interested only in the device equals to desktop. It evaluates that expression and only aggregates the total sale measure only for those data which only are related to device desktop. So that's how really calculate function works. And we can build on top of this and have multiple filter contexts if we need to. There are 4 key functions that calculate can do. One is it can add into a filter. Okay, so imagine I think I just created a measure called desktop sales, and let's see how can I add in. So this is a desktop sales, and just watch what happens. Right now it is total sales for the month of January and total sale in the month of January for desktop sales. But this is across entire time dimension, right? All the years of month. But if I say I only want to see 2015, so it is actually adding into the context of my filter here, and it's not only giving me the total desktop sales, but it's only giving me the desktop sales of January only for the month of or for the year of 2015. So this is really the concept of adding a filter to adding to the filter context using the calculate function. So calculate took the filter here, but also added to the context of the year filter that I already had on my page. All right. Second thing it can do is it can ignore filter. Okay. And in the interest of time, I think if I start creating all of these measures, it will take me a long time. So I think let's try to walk them through the slides, and hopefully you will be able to understand. So if I create something like total sales for all geography, which is nothing but I'm actually using the measure total sales, but for the geography dimension. So I have a dimension called geography in my here, right? So this is my geography dimension. So I want to calculate total sales for all of the geography. Okay. So if I create a measure like this, and irrespective of which state I'm using, it will ignore that filter which is there, a state filter which is there on the page. It will show me the all of geography. So that's why you see the same number is repeated, even though it is the context here is a state context, but the number is same because it is ignoring the state filter, because it is coming from the same geography dimension, or a city filter which is coming from the city right here, right? Whether I put city or state here, because I'm using a filter says all, which means ignore everything which is there and show me all the value. That's why these numbers are same for across all the states. Okay. Same thing you can do is you can create another measure which can now says I do not want the entire. In this one we did entire geography dimension, but it says I am not doing entire geography dimension. I only want to do all state dimension. Okay. So imagine a situation where you have a city which is one level lower than a state, Alexandria in this example, and this Alexandria city could be in multiple states. I think the Alexandria city in this example is in 4 states: Louisiana, Minnesota, Pennsylvania, and Virginia. So what this measure is going to do is it's going to say, I want to see the total sales for Alexandria. So that's why the number it is showing that this is the total sales in Alabama state for Alexandria. This is the which we already created. So this is a total of everything which will continue to repeat for 2015. But this is the total for all the state where Alexandria is present. Okay, so it is ignoring the state context, even though state here is Alabama, but it is actually showing the total of all the sales in Alexandria city across all the states. That's why this number keeps on repeating here. I hope so. If you see here, so this is number exactly the same which gets repeated here, because this is the total of Alexandria across multiple states, but this is the total of all using this ignore function. I hope it's making sense. Same way, we can create one more level which says all selected states. So here I actually selected 2 states out of every other state where Alexandria is available, is present in multiple states, but I'm only interested in Alexandria of Pennsylvania and Alexandria of Virginia. So that's why this total is only for Pennsylvania and Virginia, 7,737. And that's why this amount is going to repeat across both the rows because it is ignoring the filter. So this way you can build on top of using the calculate function to ignore the existing function depending on the use case that you're trying to do. All right. Another concept we can use is to use filter calculate functions. Calculate function in measures to actually update a filter. So example is if you are trying to build 2014 sale, you can say I want to calculate or add aggregate of all the sales for the year 2014. So it's going to ignore the filter which is 2015 and it's going to show you the 2014 sales, even though the screen says I'm looking at 2015. So this data is 2015, but this data is 2014 data. All right. So building on to what we learned on calculate. Calculate, like I mentioned, is a very powerful, in fact, one of the most powerful function available in DAX. It uses the filter context into and then apply it on the expression, which is a measure expression, to calculate the value for that aggregate you're trying to create. But you can also use it in an iterative function. It will iterate through the various rows in the row context. It will create a row context similar to, I think, the calculate measure we saw, which uses a row context, calculates it for each row. You can use an iterate function inside DAX in a measure to create the row context. And an example for that is SumX. So sum is a standard function that gives you aggregate, but SumX is a much more powerful function. So if you recall, we created a cost of goods sold earlier, which was nothing but a unit times the unit cost, which is coming from the product dimension using the related function. And I mentioned to you that this is a calculated column, which gets calculated for each row, and it will take a space in RAM, and it gets applied when you refresh the data, right? So as you can imagine, if you are working with large data set, calculated column is going to take memory and it will not perform good. So you can replace that calculations using a measure, using a SumX function. And what it is doing in SumX function is it is taking the first argument, which is actually a table context. So it's saying calculate for my table sales. So this is like, it works similar to the calculated column, like it works within a table context. So it will be, you use all the sales and then it takes the second argument. So what it is actually doing is it will iterate through each row, or which is given in the first argument, which is actually the sale, right? The sales table, it will go through each sales table. It will apply the second function on the, which is second argument on the sales table, and it will calculate and then give you the sum of the data, right? That sum it up. So that's why a cost of goods sold, if you create using a measure, it will give you the exact same number that we got from the calculated column. But this will be much more performant. Why is that? Because calculated column gets calculated at each row level and it stores the value, whereas this will be evaluated when you put this into the visual. Okay, so it performs better. So you may not see the difference in performance or the size of the file, Power BI file, when you are dealing with hundreds of thousands of rows. But if it starts to get into millions, you will start to see a noticeable difference in performance as well as the size of the Power BI file. And another thing that it helps is actually it avoids various intermediate columns. So think of an example, I think in the context of the data set we are working with, which is the cost of goods sold and the sales. If you have to create profit, right, which is nothing but sales minus cost, and to create profit, I will need to first create cost of goods sold. Or if I have to create profit margin, which is nothing but a profit divided by cost, I have to create intermediate columns. So if I start going down the path of creating calculated column, I first need to create a cost of goods sold, then profit, and then profit margin. Whereas if I use measures using these iterated SumX iterators, I will be able to directly create profit margin without creating those three calculated columns. Each of them is going to take extra space. So that's really the performance optimization tip for when to use calculated column versus measure. So there are a lot of functions available in Power BI and around time intelligence. So a lot of time we have to do something like year-to-date calculation. So this is an example. I'm trying to create a measure which is year-to-date sales. And if you look at my data set, again, I apologize, I'm not creating all of these things in Power BI because I'm looking at the clock and I'm trying to make sure that we wrap it up in time. But if you can follow the Excel file, the data I'm looking at daily sales for the year 2011. And so January first sale is 551, and which is also the year-to-date sale is also 551 because it's the first day of the year, but second day of the year, you add 7,366 more, but your year-to-date is going to be the sum of the first day and second day, right? This is the sum here. So if you have to create this year-to-date column so that you can calculate the total sales up to the day of the year, you will use something like this, which is a calculate function for expression sales, total sales. And you have to apply the filter context like we saw in the anatomy of the function formula. The filter context here is given based on the date dimension, which is saying that where the year is the maximum year, which is the highest year. That's why, because we are creating year to date. And the date that we are trying to calculate is less than or equal to the date we are trying to use. So if we create a measure sales year to date using this formula, we will be able to get these calculations. But it is probably too complicated, right? It's a lot of calculations. What's really actually happening in this calculation is we are first evaluating the filter context, right? So we are setting up the filter context for the date dimension, and this is working as an iterator, like we just talked about in SumX. Okay, and then it is saying that my all means like the filter context is my all date dimension, and then it's applying this expression for checking the condition and creating the filter context using the end. The year equals to the max year, and the date that I'm trying to use it is less than or equal to the maximum date for that year. Okay, and this creates the filter context, and it will filter the dates that I'm interested in, and it will apply that filter on the total sales, and that and give you the sum of that sales. That's how this calculation works. It is complicated, but it will give you the what your results looking for. But this is probably gonna make a lot of people scared that, okay, I do not know how to write this complex calculation. So what Microsoft has done is Microsoft has given you a lot of time intelligence functions. So this is the inbuilt functions available in Power BI, like dates, YTD. So the same calculation that we just saw, this whole huge calculation, that can be very simply done by using a calculate function and using the expression total sales, like what we were using here. But instead of this entire filter context, all you need to do is just call the time intelligence function called dates YTD and give the date dimension, the date from the date dimension. It will automatically take the maximum date or year in the current year, the largest year, and add up all the sales up to that date and give you the year-to-date number. So exactly the same number you will get with a such much simpler calculation. So that's really the time intelligence that gets introduced in Power BI, and that really makes the advanced transformations available. So some other example is if you are to calculate last month, total sales for the last month. So we are in month of April. If you want to see what is my month sale of month of March, you can use a very simple calculate formula, which is nothing but I calculate the total sales for the filter context previous month of the date dimension. So it will automatically know that the current month is April, and we have to look for all the dates for month of March, and it will calculate the sum of sales and give you the number for total sales of last month. Similarly, if you have to create month over month, you actually use a divide function, divide the total sales and the sales minus the last month sales by the total sales of the last month, right? So this gives you the month over month sales. So like this, you can use many other time intelligence functions available in Power BI, and then create much more powerful and compelling calculations and transformation that you are looking to build for the data analysis that you're trying to do. So year to date, quarter to date, month to date, same period last year, parallel period, previous year, lot of calculations and time intelligence functions available in Power BI. All right, so I hope this is not too overwhelming, and this gives you an overview and idea about the three foundations of DAX, building and learning DAX. I think that the concept around calculated columns versus measures, the concept around calculate function, which is actually using a measure expression across multiple one or many filter contexts, and using the context evaluation, which is a row context versus a filter context. And we saw that context in the add filter or the update filter or the ignore filter in calculate function, right? There's one other tool I quickly want to talk about, which is a performance analyzer. In Power BI, if I go to Power BI and if I go to the view, we have a tool already here called performance analyzer. So if you start recording and you start using your building your visuals in Power BI, it actually gives you the performance of each of these visuals here in the millisecond duration. So you know which DAX query or the visual is taking how much time, and then you will be able to analyze that which of these calculations is taking longer time, and then you can try to use some of the query optimization or performance optimization technique I was talking about. For example, instead of creating calculated column, try to push it into mQuery in the Power Query editor, like I did for sales amount. We can always do that for the cost of goods sold. Instead of creating multiple intermediate calculated column, use the iterator functionality and create as a measure, right? So those are some of the things that you can use to improve the performance of your transformations and calculations. in Power BI. And this tool, Power BI Performance Analyzer, it comes out of the box, and it allows you to analyze the performance of your expressions and calculations and visuals, and you can focus your energy on optimizing, which is something you see is not performing optimally. All right, so that concludes our webinar for today. I think, as I mentioned earlier in the beginning, this is the third webinar in the series of 5. So we are trying to build on top of previous webinar that we are learning. So in the first webinar, we learned about how can we use Power BI and bring in Excel kind of data source and replace entire pivot table and pivot chart reporting from Excel and Power BI and create much more powerful, compelling data analysis that can be also shared with your other colleagues, as opposed to saving the Excel file into shared folders or emailing them or posting into SharePoint. It gives you a far better experience of reporting in Excel. The next one we saw is how do we use Power BI Power Query Editor and the M query and functions to really ingest the data, create data mashups, clean up the data, and consolidate the data into data model. And we talked about the star schema and the snowflake schema, which is what Power BI really likes, because it is going to compress the data and then load the data into your memory, into RAM of your machine. So the denormalized schemas are not really very memory efficient. So Power BI does not prefers. You can always create it. Nobody's going to stop you from that. But if you want to really create a scalable Power BI solution, then building a model like a snowflake or a star schema is always going to be beneficial. And today we learned about creating complex transformation using the DAX query language, which is data analysis expression. And we talked about the foundations of the DAX journey, if I can call that. It's a journey to understand the concept of what is calculated measure versus calculated column versus measure. I apologize. And then talk about how do we use calculate functions and use the various filter context and switch between raw context to filter context based on depending on what field visuals are, what is available on the page, report page, whether it's a slicer or a filter, and where you can update the value, update the filter or ignore the filter or add on top of the filter, which is available. And then finally, we learned about some of the time intelligence functions like year to date and previous year, those kind of functions. And then next webinar, we are going to talk about how do we take all of these learnings that we have gathered so far and build visualizations to create powerful experiences and like storytelling using data. All right, and the final webinar will be based on how can we go even further than creating data analysis using various visuals by infusing artificial intelligence, machine learning, regression analysis, those kind of things inside your data visualization in Power BI. So we have a few minutes left. Sarah, I'm going to hand it over back to you and to see if there are any questions, comments, thoughts from the audience.
All right, thank you, Tarun. Right now, if you guys have any questions, feel free to type questions, comments, anything like that into the chat box on your screen, and I will read them out loud for Tarun to answer. In the meantime, we do have the upcoming webinars, as Tarun mentioned. You'll be receiving an email in the next 24 hours, and that will contain a link that will allow you to register for those other webinars if you want. You'll also receive a video of this webinar that you can refer to at a later time as well.
And the additional questions can also be emailed, right, Sarah?
Yes, so if you do have any additional questions, I'm not seeing any come in right now, but if you have any questions that you think about a later time, you can email them to Tarun at the email address on the screen, and he'll be able to get back to you and answer those questions in a timely manner. All right. Well, I'm not seeing any questions. I don't see anyone typing or anything. So, if you think of something later, please feel free to email Tarun, and we hope to see you guys at the next webinar next week. Thank you.
Thank you, Sarah, and thanks everyone for attending.